Say again?
6-3, our last class said.
The previous class. So on Wednesday we just did homework questions. Oh, sorry. On Monday we just did homework questions, right? Right.
I'll have it by Friday.
See?
I'll have the 6-3 by Friday.
Sounds good. Let's see. And then Friday we'll just handle homework questions on Friday. Whatever you need. Good? Bless you. All right.
Yeah, I forgot to tell you this. I'm gonna be gone Friday.
Okay.
Yeah, because I'm going to college trip.
Got you. Okay. Oh, cool.
Yeah,
Okay.
so and the thing it's not cooks. Okay.
Hey, buddy.
And then yeah, so the homework will just be online. We can record on it.
Yeah, if guys can, I try to remind myself when people are absent to record. So let's go with it, guys. Just real quick here, parametric equations. This is gonna be fun. I think so. So 6.4 parametric equations and further on graphing, something you guys have never done before. Here we will do. So all yours there. And I got a quick question for you. Do you guys remember what is the graphing rule to determine if a graph is a function?
It's a vertical line test.
Yes, the vertical line test. That's right. So if we are to make functions, they have to pass the vertical line test. So obviously, duh, does this pass a vertical line test?
No.
No way. The only problem we have in our world is that sometimes we need to model something that doesn't pass the vertical line test. We need somehow to make that. So a good example, which I thought that was kind of cool, is a long, long time ago in 1971, there was something called Voyager 2. Voyager 2 was launched, and the question is, does this pass a vertical line test? So Voyager 2's, so notice it kind of spirals in, right? It doesn't pass a vertical line test, right? So therefore, if we didn't have parametric equations, there would be no way that we actually can model the behavior of Voyager 2. I'll tell you what Voyager 2 is in just a bit here. And then we have Voyager 1. That was also launched. And the fun part, anybody know anything about Voyager 1, Voyager 2?
Those are the ones with the gold discs on them.
I like the golden record.
Yeah.
So I don't know about the golden record. That was interesting. That's new.
They're the ones they just like shot out in space, like outside of our solar system. They're just kind of like floating
Oh,
around.
yeah. So, correct. So
The alien ones.
the alien ones. Okay. So imagine, oh, it was 77. Okay. It was launched September. So Voyager 1 was a satellite launched in 1977. And then it was to explore the outer solar system. Could you imagine? So real quick here, I remember this. This was 2006, I believe. So from 1977, it traveled past, and I actually was going to work. This is kind of fun. And then this was the first satellite images of Saturn came through. And it was 2000, I want to say it's 2006. So could you imagine 23 plus 6, 29 years later, right? You launch something so that 29 years later, you can have pictures of the Saturn, of planet Saturn. We good? That's kind of crazy to me. So then you got Voyager 2. It was launched August 20th, 1977. So why is it Voyager 1 was launched later than Voyager 2? I'm not sure. But it was one of two spacecraft visited the giant planets again, like Voyager 1. Voyager 2 flew by Jupiter, Saturn, but the Voyager 2 mission was extended then to fly to two more planets before it reached the outer solar system. And kind of fun stuff. Anybody into astronomy or kind of planets and kind of cool?
I used to know a bunch about it.
Uh-huh.
And I had this app. Oh, I forgot what it was called. But like I could like mark all the constellations and
Yes,
stuff like that with my telescope. Right?
Oh, that is so
I fell
cool.
out of paper.
Gotcha.
And when I'm wait up, like stay up late, wait, stuff that.
There's something to happen, yeah. That's cool. Let's see. So I want to do this here. Let's do the video. This is the video of it of the two things. Oh, yeah. So what happened this year? About a month ago, Voyager 1 or Voyager 2, I don't know where it is. at this point, they're actually beyond our solar system. They're just kind of flying. And so, and then all of a sudden, I think it was Voyager 1, it started bringing back, so we're still Voyager 2, we have no communications with, right? Then all of a sudden, about a month ago, Voyager 1 started communicating. It's communicating like gibberish. It's weird that it actually started communicating, first of all, but then it's communicating. So then the computer analysts at NASA, they figured out like, oh, it's actually one of the CPUs that is on board that is actually messed up. And so what they did is remotely, this is crazy, remotely, they send a message back to the computer in order to change, right, the way the programming of the computer. So in a sense, they're reprogramming a computer from space. So they change it so that CPU number 4 is that part of it is no longer functioning. So then it would reroute the messages the way it should be without using CPU number 4. And then it came back and it was actually reporting data from outside our solar system, which is kind of, that's super cool. It reported like temperature, it reported like all this other stuff that it should, but kind of crazy, out of nowhere. I think it was like off for like 10 years, right? And all of a sudden, like, hey, I want to talk now, right? So cool. So this one is a cool little illustration. Let's see. I think I have it on here. I'm going to turn off the lights here, but just a little visual of the trajectory of Voyager 1 and Voyager 2.
Yes.
So I think I have it here. Let's see if it works. Should be here somewhere. There it is. Okay. I'll mark that and go. So Earth, Voyager 2 takes off.
See something.
And Voyager 1 takes off. So they're a month away from each other, right? Launch dates. Actually, less than that. Okay. Looks like Mars got away. I think like each second they're watching it, it's a month. I believe.
How fast?
Oh yeah, that means find out. Yeah.
Wait, so just like,
Yeah, it turned. How did it turn? Is it was called the slingshot move. What happened? It took the gravitational pull of the planet and it just enough so that it slingshots it in a different direction. So then Voyager 1 went into outer space, complete outer space. And that's kind of like the end of our solar system as we know it right here.
There's like a down bit.
Kinda. At least the way it's set, yeah.
But we should try to go out.
Now, why do they have 2 domes? I have no clue why it's 2 domes.
Those glass cups that people.
stay cold for longer because they have the double walls.
Maybe that's what the universe does, right? Yeah. Okay. Cool. Okay.
Longer.
Anyways, that's what it is right there. There is, let's see, up until this is 2010, so 33 years right here pass by right there.
Do you want to get space?
It's too big.
It's kind of cool. Okay. Oh yeah, so it does say this is called the helio pause, right? Helio pause or something like that.
Oh, the sun stop.
Right here. Uh-huh. Mhm.
Sun stop.
That's true.
Where the sun's gravity stops.
Mhm.
Wouldn't it be? Like where the sun's gravity stops, like lightning stuff. You make that up. Oh, that's pretty cool.
Seems legit.
I'm not sure if
It does.
pause is Latin for pause, but we should ask Dr.
Pause.
Bleish.
I didn't even know.
Okay, how about this one? This is the Apollo lunar landing mission profile. So this is if you kept the Earth at one spot, right? And you move the moon. Now remember, the Earth is moving and the moon is moving, right? But here it is. Does this pass a vertical line test? No. And in order for Apollo missions to take off the planet, what they did is they took off and they still used the Earth's gravitational pull again in order to slingshot them to the moon, right? So there's that piece. There's this whole concept of, man, we need to figure out how to make these like circles, but we need to make them so that they are in terms of a function. Are we good? I can graph it and it graphs according to numbers. So how in the world do we do this? So if you have a calculator, if you want to take it out, and I have two as well.
Yes, bro. Did you watch it? Thanks.
Just as stupid as I expected.
First person to raise your hand for the calculator. Ooh, Adrian won. Adrian won.
So everyone was going crazy how it was.
Thankfully not. It was also like 9 o'clock at night. So.
It's like 3 o'clock, everyone was like. Well, it's banging,
All right, so taking a calculator here, turning it on, and we're gonna do a completely different thing. I don't think you've ever done this before in your calculator. So let's jam with it here. So, all right, turning it on, and then we're gonna go to two things happening here. We're gonna go to the mode button. All right, I should turn on lights here so we can remember.
I like
There's somebody who wears a suit.
Oh, like the chit chats.
So let's see. So having the calculator here, you go to the mode button, and then you're gonna go over here. You're gonna go and click par. Or we could call it parametric equations. Parametric equations. I think this is the first time we're doing this.
Yeah.
So you're going to change the function, the way the calculator processes. So go down here and boom, and you're going to go to parametric equations. Click enter, make sure it's highlighted, and then you can go to second and quit. So back to the home screen, or you can go just to y equals screen and notice what happens here. It has changed.
Whoa.
Now you have
Wow.
Are we gonna need to do the horizontal line test instead?
There's no test. Everything's our functions. Everything is a function.
Okay.
So notice you have this. You have something called x1, and then you also have y1. So how do you make things that are circles? What you do is you make the x coordinate to be a function, and then you make the y coordinate to be a function. That's how we do it. And so, yes, absolutely. And they're independent of one another completely. Which is super cool. Okay, so then let's go like this. If you guys can, we're going to punch in some numbers here. So can you guys punch in 125? Cosine. And then when you go over here to click on your variable button, it is no longer X anymore. It turns into a T.
Wow.
Wow.
Just T right here, capital T. Because that is your variable. And then keep on going. Let's close off the tangent. Close off the cosine. Let's go to the next one. Now you must have an X and a Y pair. We're good? So then this one we're gonna go, I'm gonna go with 125. And make this to be a sine T this time.
Oh, very nice.
All right, and then we're gonna go to window. We gotta change a few things here. So now notice a few things here.
Is T and X and Y.
Yes, there's this extra T that's added because T is now your variable for your X coordinate, and T is the variable for your Y coordinate. So here's what it does. We're going to do this in radian measurements. So the T minimum is where you start calculating T. T max is where you stop. We're good? And T step is how often you want the calculator to calculate. Good? So let me put in the numbers as we put it in. So 0, 0, right? You go down. And this guy you should recognize as being 2 pi. Is that right? So if you click on 2 pi on your calculator like this, We're gonna do that real quick here. 2 pi. So I want 1 revolution, basically. That's what I want out of this. And then what are my steps? My steps is going to be pi divided by 4. Those would be my steps. So then when it hits pi over 4, it's going to calculate for me and it's going to plot that point. We good? Then it's going to go next one. It's going to plot pi over 2, then 3 pi over 4. And so let's see what happens there. Now, remember how we made ours 125? Our window has to accommodate to it here. So our x-min, let's make it 100, negative 150, positive 150, because I want the 125 to be in our window. We good? So then my scales, so those little hash marks that we have, you know, we can probably make them into like a 10. And so same thing here. So negative 150, 150, and 10.
Wait. Hey.
And let's stop there. You guys tell me, make sure you guys are all
Okay.
good to go.
Whoa.
Okay, White, are we good there? Or any,
Just-
let me check here.
Yeah.
Whoa.
Negative 150, 150, 10. Oh, yeah. And then so X will be negative
so
150, right? So sorry, 1 up. One up.
Uh-oh.
I go to still.
Yeah. Just like-
And then
That was
you
good.
delete that one right there because you put in a negative sign, but then I put no number afterwards. Is why. Put this little
So impressed with us. And I was
let's
like,
go up here.
So. What the?
Sorry, click enter.
Oh, bro.
That
Broke the calculator, what? I think we broke the calculator.
Uh-oh.
Hey,
paso.
Whoa, we just figured out how to break a calculator. Seriously.
Why? What did you do?
I don't know.
Need to be the motivators, hopefully. Yeah.
150, 10. Negative 150, 150.
Thanks so much.
All right, now we're all good. And some people have done it already here. They graph this guy, right? Can you guys click the graph button? And then it turned out to be something like this. Is that true? What? Do you guys something have different than that?
Way guy, bro.
No. So what happens is at t equals 0, right? It calculated this little dot right here. We're good? And then what happened at pi over 4, it calculated this one right over here, and then it connected it with a straight line. Okay? Uh-huh. So we'll do it manually in just a bit. No, not 3-dimensional. It's still 2-dimensional, but two variables at the same time, right? 2 equations at the same time. So at pi over 4, so yeah, that's cool. We'll do it manually in just a second here, but
Get the X and then the Y and then just plotting that.
yes,
Is it trying to make a circle?
it is trying to make a circle, but the only thing is, notice when we do our calculations, right? It's pi over 4, right? So we only have how many calculations here, guys? 1, 2, 3, 4, 5, 6, 7, 8, and 9, right? There's only 9 calculations that we did. And so what it does, it just connects it with a straight line.
Mm.
And so let's do a few more things here with this graph. And this may take 2 days here because it's kind of a fun one to sort out. 2 days. 2 days.
Pi over 4 value more, does that mean?
Oh, okay. So yeah, let's go to it. If you make it smaller, that means there's more corners and they'll connect a little bit better. Yeah.
A lot.
Oh, okay. Interesting. Okay. So let's go back to our window and let me check.
Twisting.
Sorry, it's not the
All sorts of. Bomba cloud. Flash cloud. Go straight that way. Boost the right. Boost the left. Boost the right. Boost the left. Go straight that way. You can't miss it. Boost left. Boost the right.
break out
Straight. Miss it.
job on.
Where are the bathrooms at, eh? Boost the left. Boost the left. Boost the left. Boost the left. Go straight.
2 par 7s. So it looks like a little And so let's change a few things here. And I'll let you guys go crazy just for a second as well on your calculators. So let's go back to the T step. So 2 down,
Window. Oh, back to window. All right.
back to window. Back to window, go down to T step.
What? What color code?
Okay, and then you're going to change it now to pi divided by 12. Good.
Wowzers.
Pi divided by 12. So you guys should have a 0.26 now, right?
Time.
Everybody good there?
Yes, sir.
Now let's graph it now. So now, oh, awesome.
Oh,
Does that
very
look like what it
nice.
should look like? So now what we did, instead of having it as pi over 4, which is a here connecting with the straight line now we have every like 15 degrees, right? We have a little point. And now because it's still doing straight lines, it's actually more of a curve. Are we good? Now the only issue I still have is this does not look like a circle. So here it is. Did you guys go? Made a?
Pokeball,
Oh yeah, that is so cool.
kind of.
How to catch them all is this?
Got it, Kessler.
That's awesome. Okay, so now go to zoom menu. Zoom menu, and we're gonna go to number 5 called the zoom square menu. So not the mode, just go to zoom. Zoom, go down to number 5. And you should get something looks like this.
Very nice.
So now we've just discovered is this is actually a function, right? Because I was able to do it by functions, but it is circular in nature. Starts here. Oh, interesting. Hold on, guys, real quick here. So this it goes exactly how our trig function unit circle goes, doesn't it? Starts here and it goes like this. Right? Perfecto.
Excellent.
Okay. Let's see if I have anything else here on the video here. So there it is, guys. This is, I think that's pretty cool. Okay, so next, what happens? So what happened here is it changes this automatically for you. So what happens when you click square, it kept the Y value exactly the same like this right here, right? But because our screen is kind of rectangular instead of square, right? It extended this out so that it has that little ratio aspect. So it's a perfect square inside and that's the way it should be seen. Okay, okay. So let's do this here. I think I could do this on my calculator here. So let's go just a little bit crazy now. We're good? So I'm going to go off of, let me, you guys grab your calculators here and let me go off the show here. Let me jump to my calculator. This is kind of fun. Desktop. Let me find mine. Boom, and I think it's down the bottom here. No, I'm on TI-83. Yeah. All right, there's my calculator. So I'm going to just quickly go to what we did before. Move it over. All right. And y equals is there. That's what I don't want, right? I want to go to mode. I want to be in radians still, but I want to be in parametric mode on my calculator.
Is there a degree measurement as well?
Yeah, you can do it in degrees. Yeah, you have to change your theta steps. So how about this? Now let's go with it here. So I'm going to go with 125, and you can follow me on this one here. 125, and I'm going to change it up to sine of t. So the x coordinate now being sine of t. Now click on your variable link right here, close off the parenthesis. Jump to this one, 125. And then I'm going to switch. So I'm switching sine and cosine. That's what I'm doing. And I want to see what switches on my little graph. Okay, are we good there with you guys? Good. And I'm going to just jump to, I got to do a little bit more settings out real quick here for you guys here. So this one's going to 0 to 2 pi. And if you switch it, we can probably do that. We switch it to degrees, then we kind of do it in degrees here. But I'll do it in a sec. So 2 pi. And what was the nice one? It was pi over 12, right? Pi divided by 12 gave us at least a good view of things here. I'm going to do negative 150 first. And then I'll do 150 and then I'll make it to a square. And we'll just keep the square as is. 10. That's cool. Go. Negative 150. 150. Cool. And then by 10. Okay. Actually, let me do this here real quick here. You guys tell me. I'm going to put this in. You guys tell me what you think is going to look like. We good? This is a trivia question here. How about this? Instead of pi over 12, I'm going to put in pi over 2. So you tell me, without graphing it yourself, what is this going to look like if I put pi over 2? A square. Perfecto. Here it is. Right? And I'm just going to make it into a zoom square real quick here. Number 5. There it is. Good there. Because it only calculated what? Pi over 2, right? It did that one, right? It connected with a straight line. It calculated pi, calculated 3 pi over 2, and then back to pi. Up to 2 pi. Okay. So we switched the sine and cosine. And I'm going to go to the window again and make it a nice one here. This is pi divided by 12 this time. And graph. Okay, so that's what we should. Oh, hold on. What happened just now?
Started.
Yeah, where did it start?
Top.
It started here on top. Is that right?
Mine's not.
Instead of here, and it goes. Oh yeah. So click on zoom, and number 5.
Oh. Aha.
Right. Okay.
Aha.
So is that good there? So it started a different spot by switching sine and cosine. Started a different spot. So let's go back over here. We're good there. Y equals, and let's do this here. Oh, did you guys know you guys can do this in a calculator? Okay, we're going to insert a negative sign. So you see this little INS right over here? We're going to go to second, insert, and it turns into a underscore over here. So all we got to do is go down over here and click negative. The negative button, and then to get out of insert, you just have to click the arrow keys out. Good there? So here's what I'm going to do. I'm going to switch the x value to a negative 125 and see what happens now. And graph it. And got to see where it goes from. Good. Starting point's the same, except this time goes this way. That is so cool. So by these, you can actually change the orientation of which way it graphs. We good? So if you have an Apollo mission that starts and it's just circle the Earth a little bit, it's going to do that then. We good? Error. Cool. Okay. So just make sure you put in a negative sign instead of a subtraction sign. But tell me if you need help.
I do negative.
Yeah, even them see. Both negative.
Oh,
yeah, that's fine. That's fine. Graph type.
Yeah.
No, I think that guy. Notice this color's symbol is a little different. That's the track.
Oh, you really?
Oh, so negative.
Oh, that doesn't. Oh, I thought I swear I pressed.
What is
It's
that?
negative.
Oh no, and then oh yeah, then no.
Screenshot of Oh.
So it's a frenzy and the graph. Let's see if that matches up here. Okay, Aaron and Garrett did both of them negative. That's what he did. So let's see if I go over here again. I'm going to make this guy now negative. Let's see what happens here. Insert a negative sign. Click enter, and we go ourselves with a graph. And then what happens? This way. Okay, so now the question is, let's turn this into degrees. We want the same exact graph, but now into degrees. We good? So you just have to make sure that your t values and your mode correspond with each other. We good? So changing it to degrees, here it is. We're going to go to mode again. Mode. To mode. We're going to change this to degrees. Right here, switch to degree mode. Click enter. Are we good there? Now let's jump to our y equals. Oh, sorry, not y equals, sorry, our window. So we changed it to degrees 80 on the mode. Right here. We just changed it to here. So let's go to window. And now from here, it's going to be from 0 now to 360. Oh, you know what would be fun? How about if I just do this? I wonder what's going to happen if I accidentally change it to degree mode, but kept this the same. I'm going to graph it. It has this little piece right here. What was that all about right here? What's this mean? It went from 0 degrees, right, to 6.2 degrees, right? And and every time it was calculating at whatever it was calculating at 0.2. So let's go half a circle now. Let's go over here. Let's go up to this one. So let's go back up to window. I'm going to go from 0, and they'll be interesting. How about if we just go half a revolution? I'm going to go from 0 to 180. And now, how fast do I want this guy to calculate?
So fast.
Every degree? Okay, let's put 1 in here. Let's see. 1. Enter. And we're going to go half a revolution, right? And go.
Oh, yeah.
Oh,
Really slow.
yeah. So notice real quick here, you can actually slow down the process. We good? So you can actually have like speed inside here as well, based on how fast you calculate. Cool. So that was every single degree calculated and plotted. That was 180 calculations. So let's go window. Let's go maybe like every 5. Let's see how every 5 does it. Enter and graph. I'm thinking, what's some good speed? That's some pretty good speed, right? Boom. Okay. Okay, so are we good there so far? Sweet. And now let's go some more here. Let's go window again. And this time, yes, we got to do a full revolution. So 360. Now, once you go past 360, you guys talk to me. What happens once you go past 360? It just repeats itself, right? There's no need to go beyond that because you're just going to be pretty much graphing the same thing all over on itself again. Okay.
So is a true circle and the thing just can't graph it, or is it actually like not quite a perfect circle?
So because you have pixels in the calculator, right? The pixel is going to have to either go higher or lower, like especially this one right over here, if you can see right there.
Mhm.
It tries to figure out which pixel am I going to use, and it goes to the closest pixel of the value itself. But it should be a perfect circle. Yeah. And on the calculators that have like more resolution, like the TI 84, right? That one has more resolution, therefore it's going to be a better circle, better looking circle. Okay, so let's see. Let's do one more. Let's do one more in here. So far we've been doing trig functions, right? Let's do this here. Let's go to, I'm going to just try this. I'm going to just try T. I wonder what happens here. One is T. Never tried it before. Let's try to see what happens. One's a trig function, one is not a trig function. Let's see what happens here. Graph. Interesting. Is that just a cosine curve in terms of time? Upside down cosine curve with 125?
Yeah, 'cause it's negative.
D, goes up to a positive 125 and goes down. So trig functions, I can still make trig functions out of these. We good?
Yeah.
In fact, if we think about it, hold on, let's go back over here. Y equals, what was my t value here? My t value was x, is that right?
Yes.
Right, so t corresponds to x, right? So it's 0, the x is 0, right? My y value corresponds to that right there, which is the negative 125 of cosine. Good. So you can go back and actually make these into trig function themselves. Okay, that's cool. Okay, then maybe some crazy one here. Let's just try tangent out of just total craziness.
Mine went up. Negative cosine, and it went up.
Okay, real quick. Let me try tangent. Let's see what tangent does. because it should just be, whoa, what's there? It's actually going up. Oh, that's right. It's only one tangent. Sorry. Let me go back to 125 tangent. Let's see what happens there. Whoa. So what happens to tangent? Tangent goes off to infinity, doesn't it? When it approaches pi over 2 or 90 degrees, right? So this graph right here goes off and it goes, vroom, goes off to infinity. Yeah, uh-huh. Yep, sure. Window 0 to 360. We were dealing with angle measurements. And then I usually do 150 and 150, right? And then I go back and I put a zoom square afterwards. All right. Yeah, and tell me if you guys get stuck somewhere here. So yeah, this is crazy here. Notice real quick here, is this a function? What do you guys say? Is this a function?
Yes, so.
Yes, it is a function, right? It's a function in parametric mode, but it is a function because I can calculate all those pieces, right, at one time. So it is a function in terms of parametric mode. Good. Correct. Yeah. Vertical line test does not apply anymore. Okay, so now let's do this here. Let's go back to the PowerPoint. Let's do this manually here now. So let's see what happens when we plot these just for our understanding of things. And we'll do that a little bit later. Let's do this real quick here. That's the one I want to do. So if we can, this is example number 1. I want us to plot this manually first, and then we're going to graph it by calculator. All right, so you guys have your notes in front of you. Did you guys write this one down? Example 1 says, graph this plane curve in parametric mode, or each pair of parametric equations here. So x is equal to 4 cosine t. Y is equal to 2 sine t. Oh, cosine, yeah, cosine t and sine t. So I want to just do one where we're actually getting the values for it. And the rest we'll do by calculator. And then I think we're just going to do half here today because enough to do all of it. So let's go for it here. So do you guys remember making a table? Remember that for functions? So this time what we've got to do is we've got to make it an extended table. So t is my variable, but then I need my x coordinate to be this guy, my y coordinate to be this guy. And then what I'm going to do is I'm going to make them into the coordinate system. We good? So you can probably just use your calculator for this if need be, right? If you want to use your unit circle, that's fine. We just want to do it together here. So if I plug in t is equal to 0, so question is this, if I plug in 0 into t over here, what is 4 cosine of 0?
4.
4, perfect, right? Because cosine of 0 is 1. And that becomes a 4. Okay, so then if I plug in 0 to here, what's 2 sine of 0? It's 0. It's going to, because sine of 0 is 0. So my coordinate is, so I begin at 4 comma 0. Are we good? All right. So then I'm going to go every pi over 4. Notice that's what we started off with. Remember how when we did it on a calculator, it didn't make a nice shape for us? But we're going to use pi over 4 just to get our dots, and then we can make the curve ourselves, right? We don't need the calculator. We're not going to put straight lines to each one. So let's go with it here. So I need to know what is cosine of pi over 4. Well, I go with square root of 2/2, yeah, square root of 2/2. Now times 4, that would make it into a 2/2. We good? All right, plugged it into this one here. So that means this guy. And you know what? I like pi/4s because sine and cosine are exactly the same, right? Except for a sign change sometimes, right? Depending on where they're at. So if I do this one, this is just going to be 2's are gone, so √2. So using your calculator to the nearest tenth, what is 2 times √2? It is 2 times √2 using a calculator. 3.7. I think that's too high. Okay, I'm going with 2.8. If you got 2.8, you're good. So then what is √2 just by itself? 1.4. Perfect. Okay, boom. Okay, so we got to do all the other ones just real quick, and then we'll plot them on a graph. And then we'll plot them on a calculator as well. Okay. This is the tedious part, but we'll make it. Promise we'll make it. Okay, are we good with this one? So can you guys do this here? We're going to divide up the room here just real quick here. Those with calculators. Katie, can I bug you here? Can you do pi/2? Karis, do you have a calculator? Ava, do you have a calculator? Yep. Ava, can you do 3 pi/4? It should be in radian mode. So cool. Cool. So just do the whole thing here if you guys can. Perfecto. Ava, if you can do pi, so let's see, 3 pi/4, right? The whole entire thing from here to here to here. 3 pi/4. And then let's see, Adrian, next one, or Olivia. Can you do the next one here? Okay, you're going to do pi. Adrian, you're going to do 5 pi/4. 5 pi/4. Wyatt, can you do 3 pi/2? So you get 3 pi/2, dividing the work out. 3 pi/2. Megan, can you do 7 pi/4? And absolutely, yeah. And Garrett, 2 pi. 2 pi is your. So, yep. All right, as you guys get your answers, remember you need an x coordinate. You also need a y coordinate. Then you need an approximation if there is any. So, Katie, back to you here. Go for it. 0. Perfect. 0, 2 is the coordinate here. So, Ava, waiting for you whenever you're ready. So 3 pi/4. Notice you can probably do this without a calculator, at least the first step, right? Because it's either going to be a √2/2 or a -√2/2, right? Your only choices there.
There you go.
Let's go with that. Yeah, absolutely. So we got ourselves 4 times a -√2/2. Okay. Ava, is that what you got right here? And then did you get an approximation for it then? Perfect. Okay. So, maybe a little bit too high. It should be 4, right, times a √2/2. And then notice it's going to be, so it's going to be the negative of a 2√2.
Yeah, it's maybe. Yeah, maybe 2.
Yeah, -2.8. Are we good there? Ava, does that make sense? Are you able to get it? Cool. Okay. All right, cool. So then you need an x coordinate, right? You need a y coordinate as well. So 1.4 for the y coordinate. And next, Olivia, what did you get for pi? Awesome. Okay, so Olivia, if you guys want to write these down, that's fine. But Olivia got a -4 and a 0. So at least write down the last column, right? I want you guys to do one by yourself, but write down the last column for your answers. All right. Adrian, I think you had 5 pi over 4?
Mhm.
Oh, that's wrong.
Perfect. So the last column should be a negative 2.8 and a negative 1.4 this time. Hey, we're in quadrant 3, aren't we? Is that right? That should be it.
Mhm.
Okay, and who had 3 pi over 2?
I did.
Okay, what'd you get?
0 and -2.
0 and negative 2 is perfect. Okay, awesome. All right, and I got myself, let's see, a 7. Tell me you guys wrote it down already? Any questions so far? So 7 pi over 4, I think it's Megan. Go ahead. Ooh, okay. So cosine of 7 pi over 4 is a positive root 2 over 2. Still have to multiply by 4. So then a 2.8 and a negative 1.4. Perfect. All right, and Garrett, what'd you get for 2 pi?
0.
Yeah, so 2 pi. If you guys do 2 pi, you don't have to do 2 pi because notice what's going to happen is 2 pi is going to give you the exact same values as the 0 value, right? So just confirming that that's true. So 40 is what we
I
got.
checked both.
Perfect. Again?
I put 2 columns, just like this is also 0.
Yep. Perfect. Yeah, it just becomes 0. Okay. So on your graph sheet of paper, here's what I want to do. Ready? You're going to just find those individual points. And remember, you got to connect them in order though, right? So can you guys go back from our list? Go back from our list here. So you're going to draw in, so from your grid, you're going to draw in where's the point 40 on your grid. Then you're going to draw in 2.8 comma 1.4. So that's going to be not perfectly centered, but it's going to be off a little bit. Okay, are we good there? So you're just graphing each one of these points, but you're graphing them as one single point on a graph. All right, and then you're going to do the next point, right? So you're going to graph 0, 2. Find 0, 2 on your graph. You're going to graph that one. So 0 sideways, 2 up. And so let me graph it with you guys in order. Then you're going to graph negative 2.8, 1.4. And so I'm just going to go in this probably a little faster than me trying to click the buttons here. So 7.4, and we get to our graph. So first point was 40. Is that true?
Mhm.
The next point was 2.8. So 2.8 sideways, but then only 1.4 up. So about right there-ish. Is that where you guys plotted yours?
Oh, you don't know that.
So the next one was 0, 2. That's cool. So 0 sideways, 2 up. And then it was negative 2.8,
Right.
but still up 1.4. The next one was a negative 40. So you kind of tell what's making now.
Mhm.
So negative 2.8 minus or negative 1.4. Then 0, negative 2. Then
Negative, whatever.
1.4. Perfect. And then at 2 pi, we got back to 4 comma 0. Cool. Okay, what in the world did we just make?
Full.
Yes, we made an oval or an ellipse. Absolutely. Do you guys remember these guys from Algebra 2? The conic sections. So, remember when Mr. Grant hopefully said this to you here? He said, like, these are conic sections. These are not functions, right? Because they don't pass the vertical line test, right? With parametric equations, we've made them into functions now. We good? I can plot a point somewhere along that line. And then now I can plot, because planets take an oval shape around the sun, is that right? I can plot the position of planets at any one time during the year. We good? Second?
Or eggs.
My understanding was.
Oh, cool, yeah.
It's not.
Right, eggs are a little bit, what is it called?
The whole day.
So,
We got to do it just slightly different. Yeah, there's a way it's mine. Yeah, Megan.
It's like what functions will look like in like normal function land and then in parametric.
Once you do enough of them, yeah, I mean, you just have to have experience, just like we have experience so much with functions and like, oh, that looks like this, right? But yeah, it just takes a lot of experience too. So let's do this one here. Let's jump off of this. Let's jump back to calculator. Oh, sorry. So when you guys connect these, right, don't draw straight lines to them, right? You want to draw them like in a curve way.
Oh.
Okay. So let's go back to our graph and let's go back to y equals. And we're going to graph these guys here. So first one was what again? Thank you. 4 cosine of t. 2 sine of t. So really what happened was, what made it to be oval shape is the multiplier 4 and a 2, right? Because those were different from each other. So it made it different. Okay. So not ready to graph yet. I need to do my window. So let's do 5 and 5, and then we're going to do a square. We good? So notice what happens if I do a 5 and 5, it really distorts it. So let's see. Since you guys are in degree mode or radian mode? What are you guys in? The majority of you guys. Raise your hand if you are in radian mode. 1. Tell me if you guys are in degree mode. Degree mode, degree mode. 1. Radian mode. Radian mode. Okay, so I'm going to go change everything to radian mode. Good? So go to mode. I got to go back to radians right here. And again, your mode has to match your t values, right? That's all. Your mode has to match your t values or else you're going to be off. So, got that. My window is from 0. Now we're going to go to radian mode. So now it's from 0 to 2 pi. 2 pi. Whoa, never mind. That's not 2 pi. Clear that. So 2. All right, we can go a little faster, finish up. Okay, and we're going to go by, what is it? What's the nice one that we did? Pi divided by 12. Is that right?
Wow. Oh.
Okay, now this one, I'm going to go -5 to 5. So -5 to 5. And now I'm not going to go by 10s. I'm going to go by 1s. So -5 to 5 by 1s this time, since our graph is a lot. Okay, you guys tell me when you're ready for graphing. Ready? So graph it. And the graph goes like this. Ooh, very much elongated one, right? But I know that's not what it looks like, right? Because we're not in square mode, right? So we go to zoom and we go to standard. And that's the shape of it more so. What do you guys say? Ice skating rink, is that right? About-ish?
Mine wasn't really.
Okay, and to finish off the day, we just finished up about 6.4, a little bit of half of 6.4 here.
Plot the 4 points and just draw where
I love that.
them
Why it's reading the one.
on the.
So again,
It's just like annoying.
The 4 on the axis.
I guess you can, yeah, then as long as you know how you're going. Yeah.
And have names.
So class, real quick, can you guys do this one by yourself? Go. What happens if I have a -3 at the end? What happens if I have +4 at the end? What changes things up? So all yours. Can you guys grab this with 2 minutes left?
Probably not. Maybe we can. Megan's got this. Lock in, Megan.
It crashed me as oh. Okay, I'm in reading.
And let's go with it here. So, all right, we are still in radian mode. Uh-huh. I don't think so.
He doesn't like me.
All right, let's go with it here. So
No,
I'll go across here.
I think one.
3 cosine -3. Okay, so boom. 3
One yesterday.
cosine of
One
t
years ago. One on Monday, one on Tuesday.
-3. Doo-doo. Next, 3
Sunday.
sine of t
What?
plus 1.
Wait. You just show.
And we got ourselves a graph.
Andrew, yeah.
Okay, so what did the -3 and the +1 do?
Don't know what.
So I got a little ring.
Oh, interesting. Okay, let me see. Because okay, so let me see what you have for as far as.
What's the net?
Okay, you put a 3 inside there. Okay, gotcha. And you most likely are in. Yeah, perfecto. So when you so remember this moved it horizontally like this, right? Put it inside the function, it twists and runs. It's a twist. Uh-huh.
Why did it go?
All right, guys, we will continue this on Friday. Have a little bit more to do
Graded. So it's like
on Friday. Finish it. What do you guys say? Is that pretty cool?
but it's like we're supposed to know them, but it's like not graded, so it's like